Okay, question 59 from chapter 2. Which of the following structures represents a cis isomer? So this is actually a pretty easy question. The thing you have to remember is what you're actually trying to compare, and what you need to remember is that whether something is axial or whether something is equatorial is not really the big thing. That's not the mode of comparison. But we'll go ahead and classify each just to make sure we're okay at classifying as axial or equatorial. So we'll just go through each one of these. So sub-question A, or structure A, we've got two methyl groups, and that'll be the motif for all these others. So B, C, and D, they'll all have two different methyl groups. So first question, axial or equatorial? The axial will always be completely vertical, either pointing up or pointing down. So if you see something vertical, you're going to say axial. So this guy's axial, and because this is, coming up from the ring, this is going to be axial up. So this is axial, and it's also up. And this methyl group is again vertical, completely vertical, and it's coming down from the cyclohexane. So this is still axial, but this is now down. Okay, so again, we're wondering about cis, and the alternative is going to be trans. So the fact that these are both axial doesn't have anything to do with whether they are cis or trans. Whether it's pointing down or pointing up, that's the big comparison that you need to make. So up and down, because one's going up and one's going down, this is actually going to be a trans molecule. Okay, so the next thing that we have is same thing, we just have the methyl groups in a slightly different orientation. So again, we have to figure out whether it's axial or whether it's equatorial. So unlike the axials, equatorials are always going to be at a slight incline or decline, at kind of a diagonal. So if you see a diagonal, that's going to be equatorial. So this methyl group, because it's not completely vertical up, this guy is going to be equatorial. And so it can either be pointing up towards the middle of the ring or down towards the middle of the ring. So it's all in reference to the point of attachment. So thinking about what else we have here, we have a hydrogen right here. So this guy is hydrogen axial up. So this methyl group is equatorial, and it's facing in a downward direction. Okay, so we're going down this way. And the methyl group here from this point is going up this way. So this methyl group right here is going to be equatorial, and it's going to be down. And this methyl group right here is going to be equatorial, and it's going to be pointing up. So again, the fact that it's equatorial, or the fact that they're both equatorial, really doesn't mean anything. The fact that one is going down and one's going up, that's the kicker. So because of that, we have another trans molecule right here. Okay, so we have two trans. So now this guy is, again, this is a methyl group. So we have a methyl group pointing down, and we have it pointing down with a vertical line, which means that this is axial. So this is axial down. And this methyl group right here is pointing down as well. You can see from this point it's coming in a downward direction, but it's not completely vertical. So if it was vertical, it would be up right here, but again, this is a hydrogen. So this methyl group is going to be equatorial, and it's going to be down. Okay, so now again, we already said that whether something's equatorial or whether something is axial, that's not the criteria that we use to figure out whether something's cis or trans. Whether or not they're both pointing down or whether or not they're both pointing up. That's the criteria that you need to use. So because they're both pointing down, these methyl groups are cis to each other. So this is the cis isomer. So this is cis. And right here, again, this methyl group is pointing up, and this is in reference to this attachment point. So it's going up, and it's axial. So this is axial up. And this methyl group, according to this attachment point, is going up as well. So this is equatorial, and this is also going up. So again, because they're both going up, and regardless about whether or not they're axial or equatorial, these guys are now going to be cis to each other. So cis. Okay. So now, one thing that just want to address, now that we've actually answered the question, a big issue that a lot of people have, a big mistake people make, is, again, drawing axial and equatorial incorrectly. So something that I see a lot is, so for this example right here, you see how there are only really 1, 2, 3 groups attached to this point. Sometimes you'll see a student trying to attach a hydrogen like this. And this is incorrect because, well, for several reasons, but the first reason that we've talked about before is that what you have to have with axial positions is as you go along the ring, they need to alternate. So you see how this methyl group is pointing up in an axial position because this one is up axial. The next axial position along the ring, let's say this is position 1 and this is position 2, we have to have a down position. So if we have an up axial, the next position over has to be a down axial. So we have to have a hydrogen here, and I'll go ahead and erase this incorrectly drawn hydrogen right there. Okay, so that's going to be the way that you would draw a hydrogen for this position. Okay, another way to think about it is if you notice how, if you walk along the bond, so this bond is pointing up right here, and this bond is going up. The fact that they're both going in this direction and they're both overall going up, you'll have an up axial bond. Okay, so you see how these two bonds right here, let's go ahead and draw a different color. This bond is coming down, and if we're going in this direction, and this bond is also coming down in this direction. Because they're both pointing down, we should have a down axial. Okay, same thing over here, just gonna beat a dead horse. This bond right here is going up, this bond is going up. So because they're both going up, we should have an up axial. Okay. So that's a very quick way of figuring out if you're going to draw an axial, which way it should go. Okay. Now this doesn't work for equatorial. So again, if we were going to draw an equatorial, if we have this bond going up and this bond going up, we've already said that this, the axial is going to be facing up. But another mistake that I see quite a bit is trying to have two different groups both facing up. So you see how the hydrogen is facing up, it's going up vertically, so it's going to be an up axial. So I'm just going to kind of erase that. Another mistake that I see quite a lot is trying to draw the equatorial also facing up. So you see how in this case we have an equatorial looking thing, or an equatorial looking bond because it's diagonal and it's facing up, and this other axial bond is also facing up. So this is actually impossible. So if you have an axial going up, you have to have the equatorial going down. So this is right out, this is impossible. So because we know this axial is going up, we have to have an equatorial going down. Okay, so this would be the way you would draw that hydrogen. Okay, so it's going equatorial down. And again, please don't draw these arrows. These are just to kind of orient you. If you're actually going to try to draw the bond, you would just draw the bond between the carbon and the hydrogen. Okay, the arrows were just there to make sure it's obvious, whether something's kind of going down or kind of going up. Okay, and so just one more practice. Let's try to figure out how we would draw hydrogens attached to this orange carbon and hydrogens attached to this red carbon. So take a second, pause the video, redraw this molecule, and try to predict how the hydrogens should look coming off of this group. So go ahead and pause the video, and I'll come back in a sec. Okay, so now for this red carbon, again, the way to figure this out for axial is this bond right here is coming down, and so is this bond right here. They're both kind of going down, so we know the axial must be pointing down. Okay, and we have to have our hydrogen. And so if the hydrogen is axial and it's going down, that must mean that the equatorial group has to be going up. So instead of drawing it like this, if you drew it like this, it would be incorrect. So you have to draw it like this, where the equatorial is kind of facing up. Okay, and same thing for the orange guy right here. So if we go to the orange, we have one group kind of going up and the other bond going up. So that must mean that our axial is going up overall. And again, these are hydrogens. So we know that this hydrogen is axial, which makes a lot of sense because this hydrogen was axial and it's down. So since we're going one bond over, this is a down hydrogen axial. This must be an up hydrogen axial, so that makes sense. And so then if this hydrogen is facing up and it's axial, the equatorial must be facing down. So if you drew the equatorial like this, again, you would be incorrect because that's an up equatorial, so you must draw it like this, which is more of a down equatorial. Okay, so this is correct. Okay, so overall, not a difficult question, just takes a little bit of getting used to.